Imagine this. Your IoT project is running perfectly. The sensors respond on time, the data updates smoothly, and everything looks stable. Then suddenly, without warning, the entire system collapses. The board freezes, the Wi-Fi drops, or the device simply shuts down. But the failure didn't start today. It started the moment you chose the wrong board. Because in IoT, the board you pick is the foundation of everything that follows. So let's go back and understand the 8 boards that define how modern IoT is built. Once you understand them, you'll never choose the wrong board again. ESP32. The king of modern IoT, the ESP32 is one of the most popular microcontrollers ever created. It uses a dual-core processor running up to 240 MHz and includes built-in Wi-Fi and Bluetooth. It supports Arduino, MicroPython, and the ESP IDF framework, making it extremely versatile. The ESP32 can host web servers, run displays, control robots, stream live sensor data, and even execute tiny machine learning models. It also comes in many variants, such as the S3, C3, W-Room, and W-Rover modules, each built for specific types of IoT workloads. If modern IoT had a default board, it would be the ESP32. Now that we've covered the most widely used board, let's move to a microcontroller known for precision and reliability. Raspberry Pi Pico and Pico W, the precision engineer. The Raspberry Pi Pico introduced the RP2040 chip, designed entirely by Raspberry Pi. It uses a dual-core 133 MHz Cortex M0 Plus processor and supports both Arduino and MicroPython. The Pico became famous for its PIO system, a programmable I/O engine that allows extremely accurate control of signals. This makes it ideal for robotics, displays, motor control, and other real-time tasks. The Pico W adds Wi-Fi, turning it into a complete IoT board without increasing the cost by much. Its stability and documentation make it one of the most trusted boards in education and hobby engineering. After precision, let's look at a board that modernizes one of the most iconic names in electronics. Arduino Uno R4, the modern classic. The Arduino Uno R4 upgrades the legendary Uno with a 32-bit Renesas R A4M1 processor. It remains fully compatible with classic Arduino shields and the beginner-friendly Arduino ecosystem. The Uno R4 Wi-Fi version includes an ESP32S3 coprocessor, allowing wireless communication while the main processor handles logic. New features like CAN bus, DAC output, increased RAM, and expanded flash memory make it far more capable than the original Uno. The Uno R4 keeps Arduino simple, but finally brings it into the modern IoT era. Now let's shift from beginner-friendly boards to raw processing power. Teensy 4.1. The performance monster. Teensy 4.1 runs an ARM Cortex M7 processor at 600 MHz, making it one of the fastest microcontrollers available. It's used in audio processing, large LED installations, high-speed robotics, and advanced art and engineering projects. It supports features like USB host capability, Ethernet, massive memory, and high-speed I/O, all while remaining compatible with the Arduino environment. Teensy 4.1 is built for ambitious creators who need extreme performance in a microcontroller format. After extreme performance, let's return to the board that made IoT affordable. Node MCU ESP8266. The board that started the IoT wave Node MCU is built on the ESP8266 chip and was one of the first boards that made Wi-Fi accessible and inexpensive. It can be programmed using the Arduino IDE or Lua and became a standard choice for early IoT projects. People used Node MCU to create home automation systems, temperature sensors, data loggers, and basic web-connected devices. Its simplicity and low cost made it hugely popular among beginners and students. Even today, it remains a reliable choice for small and budget-sensitive IoT projects. Next is the board that introduces many hobbyists to real embedded engineering. STM32 Blue Pill, the entry to professional embedded systems. The STM32 Blue Pill uses an ARM Cortex-M3 processor running at 72 MHz. While the clock speed may seem modest, its architecture makes it extremely powerful for real-time control. Its ADC, PWM, timers, UART, SPI, and I2C subsystems are more advanced and stable than those of basic Arduino boards. Because of this, the Blue Pill is used in robotics, drones, CNC machines, industrial controls, and 3D printers. It can be programmed using Arduino, Platform I/O, or STM32 Cube, making it accessible yet professional. Now let's look at a family of boards designed for compact, low-power, and wearable IoT applications. Arduino Nano Family Compact Innovation. The original Arduino Nano became popular for its small size and breadboard-friendly design. Nano Every upgraded it with a modern 32-bit microcontroller, offering more capability in the same compact form. The Nano 33 series expanded into IoT and Bluetooth. Nano 33 IoT includes Wi-Fi and BLE. Nano 33 BLE focuses on low-power Bluetooth applications. Nano 33 BLE Sense adds built-in sensors such as an IMU, microphone, light sensor, and temperature sensor. These boards are used in wearables, mini robots, smart toys, gesture-based devices, and compact IoT systems. For the final board, we move to a classic known for its massive I/O capabilities. Arduino Mega 2560, the I/O workhorse. The Arduino Mega 2560 uses the ATmega 2560 microcontroller and is known for its large number of pins, 54 digital pins, 16 analog pins, and 4 serial ports. This made it the standard board for 3D printers running Marlin firmware, as well as robotics, CNC machines, and large sensor arrays. It isn't fast and doesn't have built-in wireless features, but its stability and expandability make it ideal for complex wired systems. Conclusion: these 8 boards represent 8 different approaches to building IoT systems. The ESP32 for modern wireless projects, the Pico for timing and precision, the Uno R4 for learning and prototyping, Teensy for high-performance engineering, Node MCU for simple IoT tasks, STM32 for professional embedded systems, the Nano family for compact innovation, and the Mega for large, I/O-heavy setups. Understanding why each board exists helps you avoid choosing the wrong foundation for your project. And once you choose the right one, your IoT ideas can finally work the way you imagined.